Well, good afternoon on this webinar about the impact of robotics in food processing. We are here in the studio of Wageningen University Research, but it will be a mixture of online and live presentation about food robotics. We also would like to make it a little interactive, so we have a few polls. There's the opportunity to ask questions. And this is how we would like to guide you through this webinar. What are we going to do today? So we will start with a small introduction on what AgRoboFood is, how it can help you with your own robotic ideas. Then we have 2 keynotes, and then after that 3 shorter pitches. And we will end the session with a panel discussion. And during the session, you have the ability to ask questions. Okay, let's start with the first poll, just to get you a little bit active. I would like to know from what region you are. And we have in AgRoboFood, we have 7 regions. And we have Northwest Europe, which is Denmark, Iceland, Norway, Sweden, Finland, Estonia, Latvia, Lithuania, and Belarus. So if you are from that region, you are from the Northwest Europe, Northeast Europe. Then we have Northwest Europe, which is the Netherlands, Belgium, Luxembourg, United Kingdom, and Ireland. Then we have France and Italy, which is France and Italy. Then we have Iberia, which is Spain and Portugal. We have Central Eastern Europe, which is Slovenia, Croatia, Bosnia-Herzegovina, Serbia, Romania, Moldova, and then Ukraine, Bulgaria, North Macedonia, Albania, and Montenegro. Then we have the Central North Europe, which is Germany, Switzerland, Austria, Czechoslovakia, Poland, and Hungary. And then we have the East Mediterranean Europe, which is Greece, Turkey, Cyprus and Israel. So are you from the Northeast Europe, the Northwest Europe, France and Italy, Iberia, Central Eastern Europe, and Central North Europe, and the Eastern Mediterranean Europe? So that's what we would like to know. And yes, we have a first score, but I think we should have more attendees. Most of the people are from Northwest Europe, I can already see. We have a few people from Iberia, but no other regions are connected until now. So this is also an exercise, of course, if you really can find the poll. And what I can see now is that the majority of all the participants are from Northwest Europe, so from the Netherlands or Belgium or the UK or Ireland. Okay, let's start with a small introduction about AgRoboFood. For those who are not familiar with it, AgRoboFood is a digital innovation hub network where it has a website, and if you did not join the AgRoboFood network until now, please press the join button. You can find the join button on the home page, and you can immediately register yourself if you are an industrial partner or a business partner, or if you are a digital innovation hub, because our network is about digital innovation hubs. So we have different services what we can provide to small and medium enterprises. For example, we have a test before invest network where we can guide you to all research stations that can do validation tests for you. We have skills and training program. It's on our website, it's listed in the agenda. We have also access to finance. We will support you to find investments. And then we also have an innovation ecosystem and networking where we organize webinars, but also live events, meetups, what you can join. So if you are active in robotics, in agri-foods, you should definitely join AgroboFood. And one of the examples that we have also, for example, a pitch your robot event on the 29th and 30th of March, where you can really pitch your robot to a group of investors. How does it work? So we are a network of digital innovation hubs, and I took Wageningen as an example. So if you go to our website, you will find the services that are provided by Wageningen University Research as one of the digital innovation hubs. We are also, there are also a few projects listed. And this is how you can make use of all the digital innovation hubs. Then how is the network organized? And I also used our own region as an example. We map our networks with digital innovation hubs and competence centers. And that's a little bit how it works. So a digital innovation hub will help you from the idea to a success. And the competence centers have knowledge. So these are the research institutes. So, and the digital innovation hub also acts as a one-stop shop. So if you go to and enter a digital innovation hub, they should really help you with all the problems you have around bringing your robot to a success. And there are other organizations connected as a digital innovation hub. We have branch organization in AgTech, we have farmer association, but also public hubs and also research institutes and university which are connected to the AgroboFood network. And also CIMA, as the branch organization, is a partner in our network. In the meantime, I see that also some other regions are connected. Iberia is growing a little bit faster, but now we have also quite some number of participants from Central Europe, and still the majority is coming from Northwest Europe. It's also nice to see in the poll that the poll is still continuing. You can also go to our agenda and to our education portal. So we are now building this education portal as we speak. So, but I think very soon you can also go to our education portal and try to do some courses. But at least we have the event calendar where you can join many events coming weeks. And the whole strategy about AgroboFood is at the moment we already built our network, we loaded our network with activities, and we are now at a stage that we are really showing all activities and services to the companies. And for example, what are the upcoming events? As an example, nearby 16th of February we have live demos of innovation experiments which were also granted by our network. We do this region specific in Northwest Europe where we have 3 robots demonstrating, which are the iCatch robot, the Crover robots and the Saya Robotics robots. Then we have the Pitch a Robot event end of March, and we have a trade mission beginning of April where at least the Dutch industry will meet the French industry. So these are a few of examples which are heavily and strongly supported by our network. So that's a first introduction to AgroboFood. I think it's now time to start with our first keynote speaker. But before we do that, I also would like to start our second poll. And the second poll is about what is your profession? So are you from research? Are you a business partner? Or, well, tell it to us, and it gives us a little insight if we are dealing with industry, if we are dealing with research, or if we are dealing with others. So I hope that it is possible also to start in the second poll. I cannot see it, to be honest. Well, in the meantime, at least I can introduce Thomas. Thomas, he will give the presentation. It's Thomas Gieselsen, if I understood correctly. In the program originally it was should be done by Karsten Panch-Isaacson, but he got a baby, so that's why he cannot attend this this webinar, but I think he introduced an even better replacer, which is Thomas, and he will give a keynote about, and he's from the DTI of Denmark, and he will give a keynote about the state of the art of robotics in food. Thomas, can I give the floor to you?
Briefly about DTI, it's a self-owned institute and RTO, research and technology organization, and we help the Danish and European industry to gain insight into different kinds of technologies, and we take some technologies in, and we figure out how to use it, and we try to push.
Thomas, you're muted.
I don't think I can.
Yes.
I don't think I can unmute.
It works. It works.
Okay.
No, it's not.
So I'm not sure if it works now. Sorry.
Yes, it works.
Yeah, it's working.
Go ahead.
Okay. Okay, but is my screen still sharing?
Yeah, you have to reshare.
Yeah, I'll just reshare. 2 seconds. Yes. So okay, so today I will just briefly tell you about one challenge that we faced with a company called Dalun. They are producing spring rolls, and they are handling a lot of cabbage. So the challenge is that they are manually handling all these cabbage in a decoring machine. So each cabbage needs to be placed in the machine and oriented in a way so a machine can afterwards, a decoring machine can go in and decore the cabbage. This is done by an operator doing it manually. He is handling 20 tons a day, and it's a really repetitive work. So and then it's also this problem of that the decoring machine does not know of the size of the current cabbage. So this produces excess waste because it needs to remove more than is actually necessary. And the reason not to just buy a new machine to do this, which probably could be done, is that there's not really economical incitement to do this, because the machine is actually working, and there's a lot of needs to be put a lot of money in a new machine, and also they are challenged by the space in the factory. But a solution to this could be these the robotics, using robotics in this food processing situation. And especially in this project, it's been focused on using collaborative robots that can be used alongside with an operator, if that needs to be done. So it also means that you don't have that much requirements for the space around the robot. You can deal with a lot of, you can avoid dealing with a lot of the security issues or safety issues. Safety issues that is normally the case for robotics. But one problem that was faced in this project was to have a collaborative robot being food grade. So of course you probably all know this, that enable to use machinery in food production, this needs to be some it needs to be able to be washed and so on. So this was a problem with the general robot that you could buy. So the next part was to, besides the handling, the physical handling, was to align these cabbage to place it correctly in the decoring machine. And for this, we used some advanced AI technologies that enabled us to have a vision system that could locate the root of the cabbage, and in a feedback loop, it could together with the gripper, it could rearrange the cabbage so that it was ready for decoring. Yes, so and one side note was that using the system, we also were able to estimate the size of the cabbage, meaning that we could optimize or minimize the waste that was produced. So So this is the way that it's done today. The manual worker is placing the cabbage in these in the machine, and he needs to reorient it every time. And this is just a video showing some of the other machinery that they also have, and at some point here you will also see what is happening with the robotic solution that was worked on. So here is measuring the cabbage size, and this is the decoring machine that goes in and removes the stock. And this is then the gripper that was developed in this project. So it is able to reorient the cabbage, and then a vision system, as you will see shortly, will find the root. That you can see here that it's rotating it to search for the root, and when it sees it, it figures out how to align it. And you will see in a short time, it will also show how the AI is working. So here you can see how the stem is located, and then it's estimating how the cabbage should move in order to get it to aligned. And now with the new decoring machine, it was able to only remove the part of the stock that was needed to be removed. So so to sum up on this, Dalloon, which was a company producing these spring rolls, they gained a lot of insight into how collaborative solutions could be implemented. And of course, this means that the collaborative robots especially is good for this situations where you have space requirements or don't have much space in your factory. And then, of course, there was the problem of the food grade robotics that was solved with this sleeve that could be put on a robot, and means that it could be used for food processing. And we use this AI technology, AI vision component that was able to detect and use it to detect the root, and then use that information to orient the cabbage to be placed in the decoring machine. Yes, so what has been learned from this project is especially that cobots or collaborative robots and also robots in general have a huge potential in the food processing industry, and especially because there is some of these manual tasks that is being done in food production. Also, with advanced computer vision, it's both it's possible to handle many of these really diverse problems and with organics objects, such as localizing this root of a cabbage. This is one of the also huge findings in this, and something that Dalloon got discovered with this project. Yes, and actually I would say that would be it for me. I hope I didn't use all my time, so maybe we caught up with a little bit. So yeah, thank you very much.
Very much, Thomas. Also, for those who entered a little later, you probably have notified that we've found severe problems with our technology for the webinar, so we need to switch to Teams. So that's why also Thomas was a little later. Thomas, you can still open your camera, I would say, because we have a few questions. I at least have a few questions. So for now, is this machine implemented?
Yeah, it's not implemented yet, and that's actually mainly because, as I understand it, that the gripper still needs to a little work in order for it to be food grade. So the project handled some of the challenges with the robots being not food grade, but then also for the gripper also needs some work there. So it's not currently in production, but this project really showed the way for it to enter the processing line at Dalloon.
Yeah, and there's already a question in the chat, and also other people can ask questions in the chat. If you like the question, you can also give a thumbs up to a chat. So that helps me a little bit if the question is very relevant or not. Well, at least this question of Anish is very relevant, but it gets immediately a thumbs up. And his question is, what type of vision system is used? Was it 3D or is it, well, tell us.
Yeah, so in this system, it was only 2D. We would not we didn't need the 3D information. We could estimate both the size, and we could also locate the stem and also reorient based on the fact that we knew the position of the 2D camera, normal camera. We knew how it should be, how the cabbage should be oriented, and we didn't need a really high precision in that regard. So we could just use a normal camera.
Yeah, but you used one camera, so the cabbage needs to rotate, so that will cost you also time, or not?
Yes. We rotated the gripper rotated the cabbage until the systems the vision system located the root point, and then from there on the vision system feeded information to the robot how it should orient it, how it should turn it in order to orient it correctly.
Yeah. We have another question, which is from Susanne Verboon. She will also take part of in the panel. She has 2 thumbs up on this question, and that's about the robot. Is it privately owned by the company, or is it also available for other companies?
Yeah. So I'm not quite sure on the specific on the robot, but I think that the robot, the cobot, the collaborative robot, is actually just a standard one. You can that could be bought from both Universal Robots or KUKA or some of the other ones who made this. The special thing that was developed here was the sleeve that was put on the robot, and I think that was developed by the partner in the project, Egatech. And I guess it's available. I guess that's the point with their point in doing this in the project. So yeah, I'm sure it's available.
Yeah. So, but they can contact you, and you can guide them to the right
Yeah.
in the right direction. Okay, thank you very
definitely do
much.
that.
And there's also a competitor from the Netherlands, I know, FTNON, who also built a similar machine for the same purpose. It also brings me your project to a very nice bridge to Mark, because Mark is expert in hygienic design and how you should do this. So he is probably very curiously looking at your machine, and probably can start immediately with some comments how he can do better. But it's also a very nice opportunity to give Mark Mauerman from Fraunhofer the floor to give a little comment on Thomas, and then immediately start his own keynote. Mark, the floor is yours.
Thank you, Eric, also for this short and nice introduction. Yeah, my comment on the gripper is that maybe you will recognize some of the hygienic design features that I mentioned in my presentation in your design, and maybe also a little hint how you can do it better. At the end of my presentation, I come also to this protective covers. So maybe this is enough
Good. Yeah.
for now.
I'm looking forward to your presentation. Mark, go ahead.
Okay,
thank
so
you.
my name is Mark Mauerman. I've been working for the Fraunhofer Institute for Process Technology and Packaging. My background is mechanical engineering, and over the last 10 years, I've been working in hygienic design, cleaning technologies, with a strong focus on food processing. So I will now share my screen. So, okay.
Yes, works.
You should see it.
Yep.
Yeah. Okay. Hygienic design in robotics. So let's talk a little bit about hygienic design. Okay. The number one priority for food supply chains is to deliver safe food without customer complaints. So there is no question about this. This is the main objective. Meeting this requirement with an efficient use of natural resources and a minimum of food waste is subject to consent challenges. And I would like to have in this introduction a look on the main challenge. And the main challenge is usually in food processing, the managing of pathogens and spoilage, microorganisms, to assure that the microbial growth is mitigated. And this is a huge challenge for almost all areas in the food industry. Not only, as you see here on this slide, in meat processing, with relatively favorable conditions for microbial growth, but also in the production of dry products. Measures must be taken to avoid the microbial contamination as best as possible. And you see here, this is a nice publication from 2013. You see here a good discussion and root case analysis on how low water activity foods or dry foods are on constant pressure by foodborne pathogens. And if you want to prevent food safety issues, that you have to deal with hygienic design, since hygienic design plays an important role in food production to prevent food contamination, but also to enable first time right, so produce less waste, and to increase the cleanability. There are 4 functional requirements on hygienic food processing equipment and also food factories. The first requirement is that food processing equipment shall be easy to clean and shall protect the products from contamination. So the second requirement is that hygienic equipment should be designed to prevent the ingress of physical, chemical, and microbial hazards. On the other hand, hygienic equipment and facilities should also be designed to eliminate any areas where microorganisms can harbor or grow. For instance, dead ends in the design and pipelines, but also open products, gaps, cracks, and crevices should be avoided. This can become very important during a production where remaining microorganisms may grow very rapidly, and due to this, more frequent cleaning becomes necessary, just as it is the case in meat processing. So, hygienic equipment should also be designed to eliminate any areas where product, dirt, dust, or condensate can accumulate or build up, as this can promote microbial growth. Therefore, horizontal surfaces, hollow spaces, holes, and crevices should be avoided. And again, this can become very important during production, where product may accumulate very rapidly, and again, more frequent cleaning is or becomes necessary due to this. Yeah, these functional hygienic design requirements can be easily met by applying hygienic design principles. And this is not a rocket science. As you see here on this slide, there are only a few general requirements or principles to be applied. On one hand, hygienic equipment should be accessible to cleaning and inspection. It should be self-drainable and of course made of proper materials of construction. So usually not of aluminium, since there's an issue with the cleaning of these aluminium. Furthermore, it should have cleanable surfaces, and if necessary, a segregation into zones with different hygiene requirements should be considered. And yeah, for the rest of the presentation, let's talk a little bit more in detail and use the issue of crevices. So crevices in food contact areas are one of the main reasons for food contamination, especially direct metal-to-metal joints should not be used as they create crevices. And within the crevices, soil liquids may accumulate, microorganisms can grow, and of course, if you bring together two different metals, they can corrode. If metal-to-metal joints can't be avoided, then please use elastomer gaskets to separate both surfaces, and then they are sealed and usually easy to clean. What you see here in the picture is an example. This is an agitator shaft with many metal-to-metal crevices. You see here screw heads. You see here the shaft, and then the agitator. You have here the crevice. And for microorganisms, such a crevice as you see here, this annular crevice. For microorganisms, this is like a 10-lane motorway. Yeah, this is quite a lot of space to be filled up with microorganisms. So screw heads are another example of critical surfaces. Please eliminate exposed screw heads in your design, as they are not easy to clean. So I want to illustrate this in the video. The video compares the cleanability of a standard open thread machine leveling food. As you see here, this is the left hand, and a hygienic design leveling food. This is here on this side. So this part and this part is exposed to the environment, and this part above the screw and above this elastomer sealing here is then covered by the machine. So what is of interest for cleanability and hygienic design is this part and this part here, and of course here the food itself. So what you see in the video cleanability test, that's what I mentioned. We soiled both leveling feet with a fluorescent test soil. So green is the test soil, and then when it's removed, the picture becomes dark. And you should clearly see the difference in cleanability. So let's start here with the video. So this is without hygienic design, this is with hygienic design, and you see that screw threads are actually not easy to clean. We've cleaned here with spray cleaning, with foam cleaning. What is a normal cleaning procedure in food processing? Here you see a comparison in cleaning time. So cleaning time, of course, is one issue. So here with the hygienic design, you are faster. But the major issue here with the non-hygienic design is that it's not cleanable at all. So you always have residual soil on the surface, and this is then very nice for the microorganisms. Yeah, they can grow very easily and spoil the rest of your factory. Yeah. The answer to the question, what is the best hygienic design cable gland, of course, depends on the application. and the result of the hygienic design risk assessment, what you usually do when you design equipment for food factories. So on the left-hand side, here it is. It's not hygienic design at all due to here the metal-to-metal contact here and here and here. So this screw thread is covered by the machine, but then you have here, oh, sorry, you have here, here, and here a crevice. What is, yeah, I said it before, critical to cleaning. So the other designs are very nice. The design in the middle, for instance, the application could be in powder processing or dry processing, powder processing especially. I would choose this design. Of course, powder sometimes is abrasive material and could then wear this elastomer sealing here. So, and then at the end, you find in your product then blue particles, what the customer probably don't like. That's why I would go to this hygienic design solution. The hygienic design solution on the right-hand side, I would prefer for meat processing, since there are no crevices at all, and you have here a nice elastomer sealing. So in meat processing, I would not take any chance for crevices, since I would not like to promote the microbial growth. So you see two kinds of hygienic design, but with different application areas. From my point of view, a critical area in the design of robots is the design of the joints, which also must meet the functional hygienic design requirements. The use of O-rings to seal the joint is not a solution. Yeah, as you see here, they are forming here crevices. Yeah, if you use the standard design, this is actually a hygienic design O-ring format, but you have then here these crevices. And this is not easy to clean. Yeah, you have these crevices here. Here you see the result of a cleaning test that we did here with this design solution. And here what is white is the residual soiling in the crevices after a spray cleaning test. So maybe all the discussion on hygienic design in robotics come down to the question whether the application of robots in hygienic food processing areas is possible only with protective covers. Yeah. From my point of view, I would say with a good hygienic design, it's of course possible to use robots in direct food contact without a protective cover. But if the robot is not food grade or in hygienic design, you have to use these protective covers. But you know there are other issues with this. So if you have questions, we will support you with the hygienic design. We here in the Fraunhofer Institute can check the hygienic design of your robots and your handling devices with the new EH test method, open plant cleaning. This gives you the opportunity to have the hygienic design officially certified and to benefit from a recognition as EH certified equipment. EH is the European Hygienic Engineering and Design Group. So as a short summary, hygienic design and engineering of equipment assures that the food is safe and suitable for human consumption. Functional hygienic design requirements can be met by applying hygienic design principles. This is not a rocket science at all. hygienic design can be assessed by cleanability tests. And last but not least, hygienic design certification is available and recognized by the food industry. So that's all from my side. Thank you very much for your attention.
No, so I did a project together with Mark, and I value that very much, that project, and we learned a lot from it. And I try to apply all the knowledge also in our projects now today. And we are even taking part in also our hygienic design network in the Netherlands. So we are moving into that direction. But we are also in contact with many startups, research groups, all want to handle food. And of course, we value that very much. But yeah, can you explain, because they are all new in the field, what should they do? What's the first step if they are going to handle food? What are the roads to go? Who should they contact, so to say?
Yeah, of course. I mean, as I said, it's not a rocket science. The first step could be go to the EHEDG webpage, ehedge.org. There are guidelines available. Document number 8 is free for download. There you can find the main principles. Yeah, they are talking about materials of construction, about the roughness of product contact surfaces, about crevices, and with a little bit more explanation of what I've shown here in the presentation. All the information you can find there. So this is probably the best starting point. And then, yeah, make your hygienic design risk assessment. So check your design. You have all the information on, yeah, the food processing application. And then if you come to the conclusion that you need to do more in the hygienic design, then there are other guidelines available where you get more knowledge and more information on how to design it.
Okay.
Or ask us, we can also help you to improve your design.
Okay. So it's still possible also to ask questions in the chat. If you would like to ask questions and you like the question, you can also like the chat. So then we know for sure that the question is valued. Yeah, one question here from Lisanne. In a practice business, how much priority, progress, and interest is there in hygienic design thinking and implementation? What is your opinion about that, Mark?
It becomes more important. Industry is pushing towards buying only hygienic design equipment, since on one hand, hygienic design promotes food safety. On the other hand, you can also save a lot of operation costs. You save production time, yeah, and production time is money. Yeah. If you apply hygienic design on your equipment, then it's easy to clean. You can have shorter cleaning times, and yeah, if you save cleaning time, you gain production time.
Yeah. Another question, would you consider tools working on suction principles to be safe when handling fresh fruits and vegetables? If you would like to do bin picking, suction is for us ideal because you do not have to grab around an object. But what are the issues with using suction?
Yeah, I mean, suction is not always the best solution. If you have, if you work in a wet environment, you suck all the water and the slimy parts probably into the piping systems, and there microbial grow can happen. So what means that you have to clean the piping system, or you have to use parts that you remove each and every time in order to clean or to throw it away. So single-use parts. So it really depends on the application. In dry processing, I think it's more common than in wet processing area.
Yeah. Okay.
Someone is making noise. I think I will check if there are any other questions in the chat. No, not directly, or perhaps I missed one. Sorry for that, but it's also time to move to the next speaker. Now we will continue with three smaller pitches. Mark, thank you very much. Hope to see you again somehow. We will now move to three pitches, which are strongly also connected to our network. And the first pitch will be given by Fabio Rossi. He is from High Flexibot and automation ware. He is making automation ware for the food industry. And Fabio, thank you for being here. You're already starting to share, which is good. I would like to give the floor to you and tell us how your solutions could help the food industry.
Okay, thank you for the invitation, first of all. This is a project that's been developed in the last couple of years. In my view, very successful. I will try to give you an overview, even with the implication that this product has created by generating other products categories. So basically what we are talking about is basically a cobot that has an incredible capacity of picking that was used for a specific food, end-of-the-line food application. But it creates an incredible amount of new opportunities moving forward. So as you can see on the screen, it is based on an AMR system with basically 8 axes, so basically 4 wheels that can rotate 360 degrees. And then there is a very solid arm that is completely built by us. Actually, the key part of the project is really related to the joints that has been created for this specific arms, completely done by us. And this has several implications because we can sell those kind of joints on the industry, and they are modular and scalable, and they can be also naked. We'll show you some picture in a second. It means that if you have any hygienic application, you may build your own cobot without considering, let's say, the external chassis, or you may considering the external chassis is completely done with an hygienic, let's say, trajectory, if you like, because you can build from us, you can buy from us directly the robotics joints completely naked. So the company, thanks to this project, has been acquired a few months ago by a large industrial group that is going to bring our technology in a very large customer. And this is giving you a clear understanding that this is a very successful project. Has an impact on food application, especially on the end of the line and logistic, but also in other segments. As you can see, you can recognize some of the brands that are asking us to use this kind of technology for the logistic and end of the line production. Few words on the company. We are based on the northeast of Italy, close to Venice. We are ISO 9001, and we are also certified EcoVadis. This is a main requirement to apply that kind of technology on large account that we are targeting. Very strong collaboration with key research center, Fraunhofer, Italy, for example, that have been part of this project. They really help us a lot to really create, let's say, the software platform and the conceptual AI technologies for this project. Here you can see on top, which is the product that our company has built up in the past, or even today. This is a part of our core business. And this is on the right side, the concept of our cobot. It's completely modular. So the customer can buy even a single naked joints, or they can have a complete joint with chassis, so they can compose any kind of arm that is required. And of course, they can also have the full configuration with the mobile robot attached. One important topic is that the full robot will be composed by 16 axes, meaning that the kinematics behind is not just located on the arm himself, on the AGV, but is a full system. So the kinematics is really extended to all the axes. That's more or less the group of people, or part of the group of people that are being involved on the project. And again, I mentioned that the collaboration with the Fraunhofer was a key element for success, especially for the use of robot operating system in the evolution of the project. This is what it is. It is basically, as I mentioned before, it is a robot that can really move around with very incredible precision, even in limited space areas where you need, to do small movement to make sure that you can really pick and palletize end of the line of food production, for example. Then we can select different kind of grippers, so you can have different kind of arm configuration. There is a 3D camera embedded for the navigation system and the picking, but also some good level of safety to be compliant to the regulation that impose to really move this kind of robot without risk for human that are going to be on the environment. So, and we are in the process to do the certification of all of this. The joints, they are already certified by TÜV and even the arm. We are now in the process of certifying the full system. As you can see, several prizes being won during the last few years. We won the last SPS 2022 for robotics. That was an incredible achievement. We are also now part of large European project. In fact, we have to produce 10 units. Some of them, they will be allocated for European project. Some of those will be allocated to end user applications. I will be more specific about that in the next few slides. So there is a great fit in the agro-food industry. And of course, the pharma industry is also looking on this kind of system because we can offer agility and also, we can avoid to have a contamination on critical production system. I will mention specific application in a second. Here you can see on the left side a small video that shows, the joints completely, disassembles, and then, the composition that is on the right side, we basically compose, any kind of arm that is required for the application. It can be a small arm, it can be a large arm. One important thing that is one of the limitations of cobot, the payload can go up to 25 kilograms. That is very important when you have to palletize, for example, or do picking of very, very heavy stuff. So once again, the approach was to really use a robot that can really be suitable, not just on traditional robotic application, but also a modular system that can be applied on agro-food industry, even for external activities like picking fruits or stuff like that. So, and again, the flexibility to have joints that can be completely purchased naked, and where customer, we have already some, packaging food customers that are looking on this kind of joints to produce their own arms to be embedded on an hygienic way on their machines. Here you can see a small video that is showing which is the performance of the AMR that is on the base. You can also recognize the LiDAR system that are very effective, not just for the navigation, but also for the safety. We did an incredible job with the Fraunhofer to really specify an AGV or an AMR that can be extremely precise and really stressed in different way by using, for example, floors that are not really suitable for traditional differential robot. So, and again, analysis in which is, the precision that we can achieve with this kind of system thanks to stereo camera calibration rooms, where we basically estimate that the maximum error can be below 5 millimeters. So very precise in positioning. Then on the left side, you can see the guys building on the robot that you will see in the video. It's a very complex machine because we also have a vacuum pump inside, because to do the picking, we need to have, of course, the ability to, to pick up cartons, for example, for some of the application on end of the food industry application. Of course, gripper can be any kind of gripper that is available on the market. This is a zoom on a gripper. This is a carbonium system, and all the vacuum, let's say, pumps that you can see here, they basically are, calibrated to be used for different kind of carton configuration. And even in the case that the carton is not completely flat, we can really partialize the vacuum activities or boost with an additional pump that is embedded on the EMR, additional pressure to make sure, or additional vacuum to make sure that we can lift any kind of cartons that is available. The maximum payload can be 25 kilograms. Few pictures of our daily life during the development of the project. You can see a lot of young people. ROS was the base of all this development, and we are now migrating on ROS 2, that is the next future platform. One important topic I have to mention here on the audience is this. This is a kind of robot that can really act in real time. That is a fundamental thing to make sure that we can do actions with the minimum latencies and limited, let's say, delays from the activities. Here is the departure for the exhibition several months ago. I think it was 7-8 months ago in 2022. But basically, we won that kind of fair shows event. And this is basically, our booth during the shows. And there you can see the robot on his first movement when we did the first presentation to the press in May 2022. So the software was extremely basic at that time. And today the situation it's very much different. We are still developing advanced algorithms for his navigation and his picking activities. Here is an example of what this kind of robot can really do versus end-of-the-line application. In this case, is palletizing one end of the line, and then when he has done his job, he can move in another location and palletize again. And of course, this is the major feature of this kind of robotics. So it can be applied in different kind of situation, different kind of markets. Of course, food production is one of the target market because there is an incredible heavy and repetitive activities done by operators in picking and palletizing cartons for the end of the line food production. This is kind of job that doesn't offer any kind of quality to the human person. So, doing this kind of processes by this kind of robot is probably the best way of acting that. And the other thing is, this is limited in this case, you can see only 2 different lines, but he can navigate inside of the factory and really position himself in front of any kind of line that may require that kind of picking and palletizing process. The pallet, they can be also picked up by traditional AGVs, so they can really do the rest of the activity to transport, the pallet to the logistic activities. Business. So we have basically sold 10 of this unit. The customer are well-identified customer. You may recognize the name of this kind of customer. Zero Farm is one of our vertical farm in Italy. The purpose of this project is really to leave matrix to be carry on a specific rack for AGV transportation. So the activity of handling is completely done by our robot, so that they can move from one location to the next one. Bonduelle is another customer. They want to try end-of-the-line salad production to make sure that they can do more or less the same job. So they want to have a robot in front of the end of the line to put the cartons on a pallet, and then an AGV is going to do the transportation. But the robot himself, it can move from one line to the next one without any kind of problem. So really give flexibility and remove operator that may be required for more intelligent tasks in different areas. So this is another important project that is really giving us an incredible opportunity for the food sector. Of course, other local Italian companies that are looking for this technology, again, end-of-the-line production of gluten-free products, where there is also a discussion about contamination, but also, end-of-the-line production for olives, where again, you may have boxes with cartons, and then again, you want to move the robot from one location to another location. But also, we discovered that there are other applications for this kind of robot. First of all, I want to show you this video above, where we can present the flexibility of joints that can be composed in axes, that can be inner arms, that can be based on 6 or more axes coordinated together. There can be three joints, 4 joints, 5 joints, 6 joints, even 7 joints. And we can really handle the 2 arms in a totally independency from the original software, but also pharma. This is an example of COVID vaccine production, where we are going to use this kind of robot to really avoid any contamination from an operator. This is one of the largest producers of COVID vaccine. They are doing now the test for picking and palletizing. And I'm basically done. So the product is now available for the market. We have already fulfilled the queue for 2023. We have competitors for this kind of product. It's Boston Dynamics, you may know them, and they have an equivalent product, something very similar to us. And that's more or less my part of the presentation for today.
Okay, thank you very much, Fabio. Still possible to ask questions in the chat, and there's actually already one question. So Gonzalo is asking, how much weight can the robot carry with the arm extended?
25 kilograms is the maximum, and the arms itself can reach 1800 millimeters.
Okay, and we see that this robot is also used in some food companies like Bonduelle, but I know that yes, probably more for the packed products or not, or how hygienically designed did you do your robot? Was it an issue?
Okay, hygienic may become a challenge in the future. End of the line is not a big stuff, but for example, for the vertical farms, hygienic may become an issue, even if the cultivation may be cleaned before, washed before the process. However, once again, something I mentioned before, we are developing also chassis. And I was very pleased with the presentation of Fraunhofer before. We are looking on producing chassis for hygienic application. Actually, we are working with an Italian company that want to do this kind of thing, or they want to use this kind of joints for hygienic application.
Yeah. Okay, nice. Okay, can you also elaborate a little bit more how convenient is it to program? It's, the title of your project is High Flexibot, so I also would say that it's quite convenient to, yeah, to provide new tasks. How does that work, the whole procedure?
Software is a main task today in our development. So we are trying to use our experience in robotics, first of all, in managing AMR by using technology coming from AMR for logistic. We are distributor Geek Plus, for example. So we are developing a similar kind of concept, but also we are working in developing an operating system that can really embed some of the application of ROS in a more, easy to use platform that can really make convenient for a customer, thanks to a drag and drop technology, to build up application. So working in progress on this is actually the project itself from an hardware point of view and firmware point of view is completely defined. We are in the certification process, but the main task is to make the interface between operators and robots more easy and convenient to really speed up the execution of the task.
Okay, good. Yeah, thank you very much, Fabio. We will move on to the next pitch, and the next pitch is given by Anish, and he will also give probably some ideas to make interfaces a little bit more convenient and also try to put in the AI component in robotics. Anish is sitting next to me, which is nice. Anish, please, the floor is yours to give your presentation.
So good afternoon, everybody. My name is Anish. I'm a senior scientist here in Wageningen in food and bio-based research. I hope everybody can hear me. And my expertise is in computer vision and robotics. And today I want to give you an idea of a task that we have been carrying out for last couple of years on how we can use human information to build the robots of future. And the kind of work that we are looking at is at handling of fresh products like oranges, as you see on the screen, but also cabbages, as you saw in the first keynote. So anywhere where there is a lot of repetitive tasks on our factory floors, where humans are still involved, how can we build and design robots that could carry out those tasks? But we look at it slightly differently. When you have a new worker that joins a factory and you want to teach them to carry out repetitive tasks, you usually demonstrate to them how the work can be carried out. And we take a very similar approach. We think of our robot as a student or as an intern, as an apprentice who comes to a floor and can observe human actions and learn from those actions and repeat the task that is being executed by the demonstrators. So we set out with this goal, and what we want to do is to learn grading and sorting activities of various kinds. And the approach, as I mentioned, was that of learning through demonstrations or learning from demonstration. So learning from demonstration is actually very, very old as far as robotics goes. It's perhaps one of the earliest ideas why robots are needed. We're still very far from having such devices on a regular basis used in industry, but we think in repetitive tasks like grading and sorting, for multiple reasons, which I will get into, a technology like this might be the future. So what is the advantage if you have a robot that could learn from demonstrators? One of the biggest advantage is right now when we design robots, we design them for a particular task. So if you have a robot for a cabbage factory, you'll design a robot that is specific, for example, to handling cabbages in a manner that is suitable to the industry that you're working with. What if you wanted to use the same robot for handling oranges, as I showed in the first screen, or apples for that matter? So many times you see that there are commonalities in tasks, And if a robot could be taught to carry out more than one task, then suddenly the value of that unit is much greater than a single robot for a single task. Secondly, another thing that we're looking at, which is sort of like a side effect, when you have a small robot, and we saw multiple examples today as well, that could be placed in a factory at multiple different places, you do not need to modify the factory settings because the robot itself is small, can be placed at multiple places, primarily where currently humans are in the loop. And one of the main reasons on approaching technologies like this is labor shortage. That is an issue that is affecting especially agri-food industry overall, from production to handling quite greatly. And we are almost everybody is looking at multiple different types of automation solutions. So the approach that I'm going to present today is just one of those solutions, and there are multiple ways, of course, to approach automation. So what we are looking at is learning from demonstration. So to understand that, we need to understand what exactly is a demonstration, what exactly is an activity. So we define an activity as something that a human demonstrator, a human teacher is carrying out. And to understand that, you need to understand what exactly is happening with the body of a person. Besides the body itself, then an activity involves what is happening to an environment around it because of the action that a human is carrying out. That means you need to understand what is happening in a shared scene between a robot and a human. If you can combine all of that information together, you may have the sufficient minimal information needed to understand the activity that was carried out. And that is the first step to be able to replicate the activity as well. One of the things that I should already say beforehand is, as far as demonstrations goes, one of the things that humans use is natural language. And that is not something that we are looking at currently in our activities. We are primarily looking at visual demonstrations. And we approach understanding the human activities in two different manners. On one hand, trying to extract the atomic features. Atomic features here is how our skeleton moves when performing a certain activity. And there are two examples of me and a colleague of mine, Uldi, who are sorting the fruits that are in front of us into different categories. So this can give you a slight idea of how we look at a demonstration. So a person who's showing on a video certain types of grading or sorting tasks, and we try to summarize what is happening there by observing the skeletal movements of the body. And next, I want to get into a slightly bit more detail about the technology itself. So here is the real scenario. And in the real scenario, there are top view and the side view. The top view, we have a camera, RGBD camera, so color and depth information, to understand what is happening in a shared scene between the robot and a human. And the side view gives a very clear, or more or less clear, observation of the human itself. And why is it that we need these two views? The side view helps us greatly in understanding what is happening with the body of a person. That means we can use some of the off-the-shelf deep learning methods for pose estimation. That means we can track the joint movements much more robustly. While the top view is much better to understand what is happening with the objects in the scene. If you were only using the top view, if you were also using the top view to understand what is happening with the human body, the current methods are still not robust enough for that. If on the extreme right, you see the head of a person, and at the bottom, you see a shoe. The shoe itself, and this is just an example to show you the robustness of a method, the shoe itself is actually detected as a face of a person, including lips and eyebrows. So the top view is pretty poor for understanding the body movements. So for that, the side view, and the top view itself for what is happening with the objects in the scene. So now you have these multi-view observations. On the top, we have the RGBD information. From the side, we only have the visual information. To extract insights from these observations, from top view, we use HiResNet. This is one of the state-of-the-art object detector for understanding what is happening with the objects within the scene. And then we also use it to understand where an activity finishes. As you can understand, these are videos, and it is also critical to understand when an activity starts and an activity finishes to be able to learn from that. And in parallel, we have the side view information, from which, when we combine all of those two views, we get to understand what the human activity is. And one key step there is to use the human pose information. So poses for multiple different joints are captured together. In the plots, you see some examples of the movement of left arm and the right arm, and what happens with the wrist joints in those cases. But this is just to give you an idea of how a single joint would feature as a sequence of actions throughout a demonstration video. In this particular case, we use temporal convolution networks to understand the activity itself. So this takes me to a couple of examples that I want to show you. We do multiple demonstrations across a variety of grading sorting scenarios. In this particular one, we have an instructor who's teaching how to grade and sort oranges. That was just one video of one single demonstration. But based on that, this is a 4 times sped up video of a robot which has learned to grade and sort mandarins and oranges, well, basically on size information. One of the things that I want to show you is that if the same type of modules can be used to learn not just one task, but also multiple tasks. So the last example I will show you is that of sorting across multiple fruits. There are 3 different demonstrators which try to accomplish the task of sorting cucumbers and mandarins into different bins. And through multiple demonstrations, the robot is able to learn to repeat the task. An additional point here is that this robot is learning the demonstrations at a task level. That means it is not repeating the joint movements of a human. And learning at the task level has many different benefits. And one of the key benefits is you're not limited to the robot that we are showing you on the screen. If a robot can carry, pick, and move objects in a given scenario, the task learning is independent of the physiology of the robot. So summary, we are looking at one of the ways in which we can automate certain types of repetitive tasks in factories. And automation is already happening, and it is, well, it is very clear to me and to many of us, I think, in the audience, that this will continue to happen. And what we are trying to see is how can we make the most value from a single robotic device, which can carry out multiple different tasks. That means if today you are working on apples and the season of apple finishes and then the oranges start, you can use the same robot and try to teach it to execute a task for the second type of robot. And finally, I also mentioned that the approach itself does not rely on a type of robot, so not a physical robot, as long as it has the correct embodiments to carry out the action performed. Also acknowledgements to a lot of my colleagues who were involved in the development, but also many of those who were demonstrators to teach the robot. And this particular activity was funded by the Dutch ministry. I will stop at the impression of the demonstrations. And these are, across the last couple of years, multiple people have contributed to teach this robot to carry out a variety of activities.
Okay.
Many thanks.
Anish, thank you very much. I'm also curious, how far are we from code-free robotics?
I think that's a general question. How far are we from code-free robotics? This particular task, that the activity that I showed, the ambition is to make it easier for a non-expert to teach. So we're looking at new workers in the industry who can demonstrate, who are the teachers who can demonstrate robots. In general, if you talk about the food processing industry, I think we are still a few years away from having code-free robots.
And what are typical first tasks you see now in the food industry, which are a good candidate to automate?
I think I already started with that. Especially, I'm going to only talk about fresh food industry. grading and sorting applications, especially at the end of the line, the ones that could not be sorted right away by the mechanical devices that are there, and also packaging. I think both of those cases, robotics is very important, especially when I talk about manipulation. I'm not talking about navigation. The second part is direct and indirect manipulation. Direct manipulation, where we are handling the objects right away. This is the example that I was showing. This is the example that the first keynote speaker showed, but also indirect one, which was the last talk, where we are working with boxes, packaging material, et cetera. In both cases, a lot of repetitive action is happening, and I think that's the first place where automation will go. Yeah.
Okay, so also for the participants, it's still possible to also ask questions in the chat. But if they are not there and we are already a little bit over time, I think I would move. We will see you back also in the panel discussion. And I think it's now a good time. It's now a good time to move to the next speaker, which is Janet Bellamy. She did also the project of Cotemaco, which is a very nice project where also even the Dutch were involved. And Janet, I welcome to this webinar, and I would like to give the floor to you. Please introduce yourself and your project.
Thank you very much. So thanks for inviting me along today. So my name is Janet Bellamy, and I'm an Associate Professor of Digitalisation and Food Processing at the UK's National Centre for Food Manufacturing. And we're a satellite campus of the University of Lincoln. So for the next 10 minutes, I'm going to present a case study from our recent involvement in the Interreg-sponsored Cotemaco project, but also give you a bit of an introduction into what the National Centre for Food Manufacturing is as well. So the project itself was managed and delivered by 4 key partners. They were Zima, Flanders Make, Food Tech Brainport, and the University of Lincoln. And the aim of the project was to increase the competitiveness of SMEs across Northwest Europe through efficient man and machine collaborations. And that was in spite of a world pandemic. So the project was able to successfully deliver mentoring and support to over 65 businesses across the automotive and food sectors. And if you do want to know more about the activities and some of those case studies relating to the 65 projects, if you just Google Cotemaco, it will take you to the Robot Hub site, and all of those case studies are there for people to access and to see future events with Cotemaco. As part of the project, the university worked with One Planet Pizza, and they're a small business producing plant-based frozen pizzas for the direct-to-customer market. It's a family business, and it's led by Mike Hill and his son Joe. And I want to just take you through the story now of One Planet Pizza and get the guys to tell you what their story is.
I guess growing up, we always had a passion for pizza. It's always been one of our favourite foods.
I taught the children how to make their own dough from scratch, make our own homemade tomato sauce family recipe.
That's led to this point in time where we now are making thousands of pizzas trying to save the planet.
So our product, we believe, are the best plant-based pizzas in the world. And we've spent a long time developing the perfect base, the perfect tomato sauce, a great range of toppings.
We handcraft every single pizza. We load the cheese on. We're very generous with our toppings. Our sauce is a homemade recipe. Does the cheese look, taste, melt like traditional dairy? And the answer is yes, without any animal products.
We do plant-based pizzas, which are straight swap-ins, margaritas, pepperonis. But we love doing crazy things like macaroni cheese, new flavors, new toppings. We know we need to be constantly innovative.
It's been a roller coaster ride since we founded One Planet Pizza back in 2016. We're developing our own production site. Our team's grown significantly, and we're really picking up pace and momentum.
Our vision for One Planet Pizza is to be the #1 plant-based pizza brand in the world.
We're here to challenge traditional mainstream pizza companies to say you can be delicious and sustainable at the same time. You need to try this pizza to believe how good it is.
So it truly is delicious pizza, but you can see from the images there that they've got challenges. You know, it's a very hydraulic process, very labor intensive. The business itself is located in an isolated rural area on the Norfolk-Lincolnshire border. And COVID saw a rapid increase in online sales that meant the business had to rethink its production process. They just couldn't get staff. They were very difficult to recruit, and the skill was needed to be able to assemble these pizzas. And it wasn't just that, it was the technical challenges of pizza assembly that really meant that there wasn't an automated solution out there ready for them. So what we were able to do as part of the project was support the business to develop a roadmap to move them towards that cobot solution, and work with partner businesses as well that could provide those cobot and robotic solutions, I suppose is the best word, but obviously they're inventions as well. Historically, pizza assembly, as you can see, has always been manually performed in a batch process. So those pizzas were laid out on work tables, toppings were added sequentially with staff members following around the room, each placing one topping component on the successive pizzas. And the maximum daily production they could achieve was somewhere between 350 to 600 pizzas per day, depending on the pizza type. So as those sales volumes increased, the business really needed support to improve that production capacity, improve their efficiency, and therefore their productivity. What we did was assess the current production processes and then provide that automation roadmap that delivered that growth. So when we look at the technical challenges of that, some of those technical challenges included removing the interleaves between the pizza bases themselves, applying sauce topping to within 15 millimeters of the edge of a pizza base. And those pizza bases weren't consistently round, they were all multiple shapes. You've got this inconsistent, soft, pliable, delicate nature of toppings. And you have to be able to identify those topping components in the supply bins. You've got to determine which order you're going to pick them in. You've got the grasping issue, and then you've got the accurate placement and release of toppings once they're grasped, and swapping between different pizza types and different recipes. So what we did was put in business improvement plans that were a collaboration between the management team and the workers at One Planet Pizza to make that happen. And that roadmap was split into short, medium and long-term actions. And the first stage of automation, which was about the installation of a process conveyor and an auto sauce depositor, delivered 30% uplift in productivity. So straight away we achieved buy-in. What they've now got and where they're heading is a fully robotic solution that's repeatable anywhere in the world. And if you want to check out what's happening with One Planet Pizza now, they're in the process of raising capital to deliver that vision, with partnerships pending for that robotic, automated pizza line that will be delivered to 9 countries across the globe. So for them, it's been a real success. But how do we get there? What do we do and what's our part in this? So I'm based at the National Centre for Food Manufacturing, which is right in the heart of the UK's emerging food valley area. The team here are industry experts with that specialist knowledge of the food and drink industry. We're made up of ex-industry professionals who've worked at some of the UK's largest food producers across R&D, supply chain, operational roles and academics. Researchers and other partners are part of that ecosystem. So we're covering other academic institutions, policymakers, manufacturers, technology providers, and we don't have any favourites in that allegiance. So it's whatever works best for businesses. What we're doing is providing a storefront and a contact to that expert advice around emerging technology and digitalisation, because very often people don't know where to go or don't know what questions to ask. We've got test beds. So we have a working food factory, we have a robotics lab, and that can host pilot plants and trial equipment. And we can work quite collaboratively to deliver novel processes and ingredients. And what we're not going to do, which is what we can't do today, is give you a prescriptive description of each of those processes, because the IP remains with the business, and that's important for a competitive advantage. We are engaged in impactful research, and that's designed to make a difference across the food and drink sector. And it was interesting to hear the comments earlier about hygienic design, because if one thing is key to a successful innovation within food and drink, It's to make sure that the hygienic design is part of that initial process of putting that idea together. Because if you don't, it's a very expensive and sometimes very costly element to have to go back and redesign a piece of equipment. We take on board the challenges that industry face, and what we do is develop them into real life solutions. So we like to think a lot of what we've done and our case studies are quite transformational because we do have an impact on the bottom line. We are impacting productivity and efficiency with some of these robotic solutions. We know the problems that business faces. We see opportunities every day. If businesses aren't innovating, then they're not going to succeed. And it's in these challenging times that those that innovate will succeed and grow. And we can help with that. That's what we're here to do. So we've supported over 450 SMEs across their business journey, across different growth programs, and we've delivered lots of first to markets in products and processes. So some of those include steam infusion cooking, cryogenic cooling, extrusion, and our robotics team have delivered autonomous warehousing handling solutions through the Iliad project across Europe. And we've also collaborated on vision and weighing systems, as well as some of the cobot case studies you can see on Cotomaco. So we run a range of events, opening up access to our team and to our test beds to give you an opportunity to network and to share some of those ideas. So the range of support that we offer is quite broad, and it doesn't matter what size of organisation you are, from a sole trader to a global player. We offer a range of grant-funded consultancy services. There's innovation and support. Our factory robotics and digital test beds provide that proof of concept service for innovation that give you the minimum risk and less disruption to your business, basically. So if you'd like to know more about what we do, then please do get in touch with us and we'd love to hear from you. So thank you very much for listening today. And if you do want to understand more of those case studies, then I would suggest you go onto the Cotomaco website where you'll see 65 across automation and food and drink for you to look at in more detail. Thank you.
Okay. Thank you very much, Janet. I have a few questions to you. For example, unfortunately, we don't have drinks at the end of the day because it would be very nice to have pizzas there.
Yes.
It definitely would be something. But what kind of companies could you help the most? What is the main struggle in robotics when they contact you?
The main struggle, I think, first of all, is understanding what's available and what their actual need is. And I think whilst there's lots of equipment, shelf-ready solutions, I think when we did the Cotomaco project, we looked at a report of approximately 75% of all tasks performed in manufacturing already have a robotic solution. People can't visualize that in their factories or in their operations. So sometimes it's being able to provide that information and make that link. And in some cases, it's affordability. So I think some of the solutions that we look at and what we build in terms of innovation, we need to focus on the commercial aspect as well as the health and safety and the hygienic design of those solutions, and look at ways, creative ways of being able to fund that, whether that's through joint research and joint funding applications, or whether there's a different way that people can pay. Because it does become quite prohibitive, especially for the smaller businesses, to be able to access that level of innovation and technology. And in a lot of cases, they're taking a chance on these innovations in that they're not proven. So you're asking them to invest and to take that risk as well, which can be quite disruptive for them.
Yeah, and where does the business case not fit? And so is it a capacity of a robot, or is it the flexibility of the robot, or is it programming of the robot when you go to new tasks? Could you elaborate a little bit more on that?
Yeah, I suppose it's all of the above because, in terms of flexibility, you want to get the most out of your asset. So you need to make sure that that asset is working hard for you, whether that's a robot or a standard machine. So you want to get the maximum output and productivity improvement that you can from that robot. But at the same time, you don't want to have to redesign your factory to put that robot in. So you want it to be able to communicate with legacy systems. You want it to be easy to clean. You want it to perform consistently and not repeatedly break down. If a retailer changes the pack size, or your customer demands a different product or a different addition into a product, you don't want to have to spend £1 million on software to reprogram that particular piece of kit. So I think there's got to be more flexible solutions of how these things integrate into our existing business units. It's great if you've got a pot of cash where you can go out and build a brand new factory and drop it in and make it fit to legacy systems.
Okay. And Janet, now the Cotimaco project, I think, is close to an end. How will you continue with the work and the collaboration between countries?
So as a group, we've agreed to continue meeting at least once a year. We'll hold a Cotimaco conference, and I believe this year we're going to come to Lincoln. So everybody's coming to the UK, which is great for us. And that will continue. So we regularly host webinars and events, and it's about sharing information. All of the partner details are available on the Cotimaco site, and we continue to update that so people can make contact with individuals and groups, and we share that around the group to make sure that you've got the best match or the best pairing. So indeed, the reason I'm here today was due to an introduction from Food Tech Brainport. So, you know, the system does work. So please do get on there and have a look and use it.
Yeah, thank you very much. And we definitely also need to connect even more with Global Food, I would say.
Definitely.
Yeah. Okay, thank you very much.
Thank you.
Well, we will move on to our next agenda item, which is the panel discussion. And for that, I would like to invite a few specialists, which you already have seen. That is Mark and Anish. So Mark and Anish, I hope you can switch on your camera. That would at least be helpful. So we have already had an introduction of Mark and Anish, but not from Susanna. Susanna is also joining this panel discussion. And Susanna, perhaps you could introduce yourself.
Good afternoon, everybody. My name is Susanna Verboon. I am joining this meeting today as a representative of FMA, which is the industry organization in the Netherlands for high-tech industry. And I am there the program manager for agriculture and food processing. I am also involved in all these kind of robotics projects, because we as a FME do participate in a very big program in the Netherlands about, it's called Next Gen High Tech, in which robotics and agriculture are one of the main topics. So it was for me very nice to be part of your webinar today and learn much more about what is also happening in other countries. Yeah, so thank you for inviting me.
Yeah, thank you very much. So we have on the table, well, it's a digital table. We have Mark Mauerman, which is more from the mechanics, hygienic, somewhere between fundamental and industry, I would say. So how to apply things. Then we have Anish. Anish is from the AI and how to make things smarter, and a little bit more from the fundamental. And then we have Susanna, who represents industry. So I think we have 3 layers from fundamental and the AI part, hygienic part, and industry, what we definitely need to be successful. And I have a few questions. I would like to start with Susanna. So Susanna, if you are representing the food industry, you have a lot of members who are part of FME. What do you think that our main requirements are when it comes to robotics in food processing and the food industry?
Especially in food industry, and I think you showed it also here, I think there will be a great need of robotics in the future, because there's still a lot of manual handling going around, and I think that's also what you have been showing in almost all your presentations, that there are still a lot of people needed. No, that's a big issue, of course, that well, people don't want to work there anymore, and there's also costing a lot of labor, money to work to get people in this kind of processes. In the Netherlands, most of the people who are working in this kind of industry are coming from abroad. So this gives also very other issues like housing and so on. So that makes the one thing that companies really want to invest in. But also you see that there's still a lot of difficulties to overcome to be able to do all these kind of things that people can do by robots. So that's why I think industry is very interested in following all all the developments that are going on nowadays. And that's also why FME thinks that we can be a good partner, because we are representing not only industry, but we also are involved very much in the research programs on smart industry. For example, ASML is also a big ASML. Everybody knows ASML, but they are member of FME as well. So all the other countries. All the other companies which are in developing technology are also our members, and we hope that we are also able to make cross links so that this kind of technology is also not only invented and developed and optimized, but also scalable.
Okay, and Mark, as you are also very close to the food industry, why do we still see so many manual operation in food?
Yeah, I think the answer is flexibility. Yeah, if we have skilled workers, they are just flexible if they understand what they have to do, and if they know how to deal with hygiene and the impact of their behavior on food safety. They're quite good workers. Yeah, you can produce different things, and they are flexible. They can do the job. Robots, first they have to be available, and the other side, you need to control them properly. And I think that's an investment. Many of the small and medium size companies are not willing to do or cannot afford at the moment.
Is it also a cultural thing?
That's a good question. Yeah. Yeah. I mean, in the end of 2018, I was in London at a congress, and there was a speech on robotics and food production. And the speaker said that, now we are facing the Brexit. That time it was, no? They were in phase of the Brexit, and they said we need robots in order to replace all the manual for our workers. So I don't think that's at the end a kind of cultural thing, more kind of or question of which need do you have.
Yeah, so I think so. You are saying that the food industry is as ready as high-tech industry to apply robots. Only the flexibility and complexity of food is perhaps difficult.
Yeah, I think the main. I wanted to say that from my point of view, the main difference between other high-tech industries and the food industry is food safety and the issues you are facing with food safety. I presented the functional requirements on robots. The focus on hygienic design, and that's the main difference. In other type of industries, you don't have this high regulatory requirements on safety, or especially on food safety, and they don't have to deal with microorganisms. Yeah, so that's my point of view.
So we move to Anish. Anish, what can you offer Mark and Susanna when it comes to flexibility? So Mark, that's at least one of the issues. Let's also discuss the other issue, but at least start with the issue of flexibility. What can robots do? You need you showed something, but is it flexible? It's quite fundamental. Where are we now?
I think 2 points. Let me, add to first Mark's response. Flexibility is just the key, and just to understand why flexibility is so important. If you are a worker working in a pizzeria, right? Even if actions are, let's say, they can be made in a pipeline of actions. A worker can move from working on a stove to go to the kitchen and clean the dishes if it is necessary. We as humans, we can do almost everything that is possible to be done. That is exactly what makes us flexible. So when we look at robots, and as long as they carry out one thing, we would need multiple robots to carry out the complete tasks. So there are then two ways to approach it. One is that we make one machine that is good enough to carry out one task really, really good. That has been done in automation, for example. Right? On the other hand, if you can make robots that can fit to the current conditions where humans are already working, so when you talk about cobots, etc., and allow them to learn to fit into a certain situation. And yeah, my presentation was just about one of the ways that you can approach it. So flexibility has to be an inherent part of our design of robots to handle so many diverse conditions that kind of robot will have to face. So it's fundamental that intelligence has to be part of the design, not just the body. That's not to say that the body is not important. So the second comment is on flexibility in terms of the body itself. Handling dough is very different than handling sugar. It's very different than handling a strawberry. So handling itself, you need a lot of flexibility in terms of mechanisms as well, especially the end tools, to be able to handle all the different variety of food products that we need to get in contact with, right?
Yeah. So we have still Fabio on board. Fabio is working on a more convenient interface or programming method. Fabio, what do you think? How can we make, especially for food, when you have seasonal products and a change of product every few months? So how do we make it convenient for the worker? So you are building this roadmap. You also see that that's one of the key elements what needs to be built in food. What are you doing there?
We are in this process as a company. We are working with a large group in food, and I have to agree with one comment of Mark. This kind of full solution implementations, because it's not just one single robot that make the success of the project, but it's a combination of different kind of projects and different kind of robotics. You may have an arm that is doing an action, then you have to really program also the right gripper for the application. Then you may need a mobile connection with an AGV or an AMR. So it's really the full understanding of the problem that make, let's say, the logistic of food very effective and very impacting. Then AI, that is also very important. Now, when you reach this complexity, my point is, if you are a single small PMA, you may have a challenge because you cannot fulfill the full equation. And when you're talking with large customers, like a corporation, I mentioned in my presentation Bonduelle, we have a project with them. These guys, they want to make sure that they can really move from traditional to robotics without any turbulence, without any impact in what is happening. That means you need to have the right level of infrastructure to make sure that you can minimize the risk. So in my view, it is really making success companies, small PMA, more harmonized with a group of companies, patronage, or consolidation. Because otherwise, this large group, I mean, Bonduelle is one of the largest, of course, but there are so many others. They want to make sure that everybody is really taking his own responsibility before that they move from traditional to the next phase, that is partial robotics or full robotics. And this is, from my point of view, the biggest challenge.
Okay, well, let's move to Susanna again. Susanna, do you agree with Fabio? Should companies prepare, or should technology prepare to make it brilliant, simple, and easy to use, convenient? So where should we shake hands? And then there's the other issue, perhaps you could take that into account as well, is that food safety is the main issue, according to Mark. What also should be what will make the biggest difference? So how are we struggling here in what is the part of the food company, or the responsibility of the food company, and where should technology providers help?
I think it's not the one side or the other. I think what you say, we should shake hands somewhere in the middle, and start with. I think in this field there is still some low-hanging fruit, and maybe we should start there. You saw it already in the videos that lots of things are now done around handling of the packaging, where the food safety is a little bit less an issue than when you are really in the dough handling. Start with the easy parts and learn from that, and also start to collaborate with the food industry at an early stage, because all the things which were said about food hygienics, maybe you as a robotic engineer can learn a lot from it, but you have to learn it. But your experience is on another field, and the people in the food industry, they are already experts in food hygienics, and they already have machines which are already engineered around that. So you start to collaborate and learn from each other, and go looking for the right opportunities. And maybe I can still also for the Dutch people around here make some advertisement for the trip to France in April, where this is especially where meeting companies is one of the big themes around there, but where we are going to visit Bonduelle there. So go and join them and get in contact with the big food companies in France. So it's an open invitation, and it's still possible to join.
Okay, thank you very much. I would like to close with the last round. So all the panelists, I would like to give all the panelists the floor to give your top message to the audience. So Mark, can I start with you? What is your top message to the food robotics audience?
Yeah, my top message. I really like what Suzanne said, that start to cooperate. Yeah, shaking hands. The food production specialists, they have a lot of insight into food hygiene, and at the end, it's not really a rocket science. Yeah. The robots, the design of the robots must be ready to be used in direct food contact, and I think every company knows what the issues are with their products, and then just start doing the cooperation. I think that's the best way to learn from each other and to make good products.
Okay, Anish.
Yes, I think that's the main thing that came to me as well. I think a lot of it is about communication across different points of views. So on one hand, Mark, just like Mark said, it's about interaction of us technologists with the food industry, because there are a lot of learnings for us available there that could benefit us as well, including in building our solutions. But I think it's also the other way around. There's also an interaction from the other side as well. I think a lot of solutions that are coming from robotics may have value to the food industry as well. I think this middle ground needs to be found in many cases.
Okay, Fabio, you are still here. Open
I
your
mean,
camera.
my experience, I mentioned before, this industry is ready for the change. I think is ready for robotics. They just want to make sure that we are delivering packages that can really work and be implemented. I agree with hygienic. I agree with safety. All these pieces has to be in the right perspective. But at the end of the day, the industry is ready for the move. They have challenges. People, for example, they cannot find people for this kind of job. That is a tremendous challenge. That make their mind setting completely different. Very open mind for robotics, very open mind for next generation robotics. That is modular, scalable, and connected. So means not anymore the traditional old-fashioned automotive lines, but a totally different kind of robotics where collaborative mobilities and sensor and AE can impact on it. But at the end of the day, they want to make sure that they don't have any blackout on the production. And this is a tremendous challenge.
Yeah, okay, thank you very much, Fabio. Susanne.
Well, it's difficult, of course, to be in the end now, but I hope I can still add something. What I've not heard from you yet is other things which are, I think, very important is about connectivity and uniformity, especially when you're talking about data. And I think also there that it's good to be in contact with the food companies already, to know what kind of data they need, especially also around food hygienics and traceability. There is also there's a lot of need of know what's happening in a factory. Make sure that the applications you are working for with can connect with the systems that are already working in the factory and do have the same kind of language.
Okay, good. Thank you all very much. Also, all the visitors to this webinar, thank you all very much. This is how I would like to close this webinar. Be aware that there are many new activities coming up from AgRoboFood. If you are not connected, please press the join button on the homepage. Important event is coming up. It's the Pitch a Robot event. It's the trade mission to France. You can join. The Pitch a Robot event has big prize money this year, 200K, divided by 5 applicants of the first 5 winners, so to say. So if you have a robot that could be pitched to an investor's podium and also to the jury, then please sign up to this event. Okay, this is my last voice, and I would like to thank you all. And sorry for the inconvenience at the beginning, but hopefully you had a proper webinar at the end. Goodbye.
Thank you.